Hello everyone, let's compute this indefinite integral. For this integral, we are finding the antiderivative of the function 1 plus x squared all over square root of x. And it's in the form that we cannot really find the antiderivative directly. So we need to do something to the function so that we can turn it into or break it down into something that's manageable for us. Okay, so how do we do that? And we actually see that there are three terms in the numerator and there is only one term in the denominator. We can actually write this fraction as the sum of three fractions so that we can see if we can integrate each of those fractions directly. Okay, so how do we do that? We can just write this as the integral. So for this step, we are not doing any calculus. And as you can see here, we are still keeping the integral symbol. And then we are going to break it as what? The first term, which is 1 over the square root of x. Okay, so that's our first fraction. Second fraction, we have the second term and then over the square root of x. So we have x over the square root of x. And then now the third term, it would be the x squared, which is the third term, right? So x squared over the square root of x. So we have x squared over the square root of x. Okay, but if you look at each fraction right here, they still don't look like anything that we can integrate directly. We still need to do a little bit of more work to change their looks. So for this one, we can actually write it in x to some power. And actually for all three fractions, we can write them in the form of x to some power so that we can reverse the power rule. So how do we write all three fractions in the form of x to the n power? Yeah, so for the first one, let's take a look. We know that this square root of x is x to the 1/2, but it's in the denominator. So let's do some stretch work above. So here, that's actually looking like 1 over x to the 1 over 2. You see what's going on here? We can actually write it as what? X to the negative 1 over 2. Okay, so that's nice. And then what about this one? This one actually looks like x over x to the 1/2. And then according to the rules of exponents, we can actually take the top exponent minus the bottom exponent and then combine this into a single x to the power function. And so we are going to get what? We are going to get x to the, if we take the top power, which is 1 in this case, minus the bottom power, 1 minus 1 over 2, then we are going to get positive 1 over 2 as the exponent for the x. So that's our second term. And then what about the third term? Let's look at this one. This is x to the second over x to the 1 over 2. And so if you take the top power, right, just like the previous term, if you take the top power minus the bottom power, 2 minus 1 over 2, then we are going to get x to the 3 over 2. So 2 minus 1 over 2. 2 can be turned into 4 over 2 minus 1 over 2 so that we get 3 over 2. Okay, so that's how that works. Okay, so now all we need to do is to integrate each one term by term because we're finding the antiderivative. So in this case, we're actually finding the antiderivative of this one, finding the antiderivative of this one, and then finding the antiderivative of this one, and then we sum them up all together. Okay, so now reversing the power rule. And because we are already finding the antiderivative, so we are not going to keep the integral symbol anymore. So we are going to get what? We are going to get x I actually don't remember which color that was using. I think it's this one. Okay, so now that works. So now we are going to add 1 to this power. So adding 1 to the 1 over 2, we are going to get positive 1 over 2. So that's our new power. And then don't forget that I left some space in the front because we're reversing the power rule. So we need to multiply this x to the 1/2 by the reciprocal of the new power that we have here. So we are going to have 2. That's the reciprocal of the 1/2. Next one. Next one is the x to the 1 over 2 right here, right? So we add 1 to the 1/2. We get 3 over 2. And then in the front, we need to multiply by the reciprocal of this new power. So we are going to get 2 over 3. So that's simple. Continue with the last term. And then for the last term, we are going to have what? X to the, now if we are adding 1 to 3 over 2, then we are really just adding 2 over 2 to 3 over 2. So we are going to get 5 over 2. And then its reciprocal would be 2 over 5. And we put that as a coefficient. And then because we're finding the general antiderivative for this function, so we should also include what we call the constant of integration. So we usually use capital C to denote that constant of integration. So let me write down its name. This is called a constant of integration. Integration, okay. Yeah, because the process of finding this integral is called integration. Okay, so that's how we handle this problem. And it doesn't really require any difficult techniques or tricky techniques. All we need to do is to do a little bit of the algebra manipulation, change their looks, and then once we turn each fraction in the power form, then we can integrate directly. Okay, so that's it for this problem. If you like this video, please subscribe to my channel and then give me some support. And please also leave some comments. I will really appreciate that. And then please also check out my other math videos. I think they're nice for reviewing your calculus, or if you're just learning calculus right now, I think they should be helpful to you. I try to cover a lot of different types of examples for you. Okay, and then also make sure that you subscribe to my channel and then give me a like. Thank you for watching this video. I will see you next time.